To keep yourself updated, subscribe to Indigolearn and click the bell icon.
Often we see a lot of people saying that CA exam is one of the toughest professional exam that students appear in our country. So if I ask them what is the reason why they think so, they tell me lot of numbers. So they tell me out of every 100 students who start preparing for CA entrance exam, not more than 4 or 5 people ultimately become the full-time chartered accountants who complete the final exam. So if I look at the number, right, one way of interpreting this number is using the concept of probability. So if I ask you what is the probability of you becoming a full-time chartered accountant now that you have started preparing for a foundation course, probably some of you might say it is 4% or 5%, which indicates why the course is so much valued and why the CA professionals are very respected in their field, right. So probability, the topic that we are going to discuss now, is a very interesting topic, right, because probability discussion was there almost more than 300 years back. Initially it was considered to be a part of mathematics, but over a period of time the application of probability became so huge that it became a separate topic altogether. Nowadays we see probability being discussed as a part of statistics, right. Now you have heard lot of people speaking about artificial intelligence, lot of people speaking about different technologies, but lot of programs which run behind the scenes are derived based on the statistical models and based on probability, right. So that we are not going to discuss in our syllabus. What we are going to discuss is very fundamental principles of probability and how probability applications can be used for various kinds of problems that come in your exam. And also remember guys, advanced understanding of probability, that means forecasting, will be used once you start becoming a full-time chartered accountant and once you become part of a big company where you are expected to do projections and so on with respect to the future. Then good understanding of probability along with statistics that we are going to discuss subsequently is very important, right. So from that angle, probability is very interesting and very important topic, right. So let me ask you a simple question guys, okay. Assuming I toss a coin, right, what is the probability that you get a head, or what is the probability that you will get a tail? I think most of you would be saying probability of getting a head is 1/2, same applies even for probability of getting a tail. So the moment you say 1/2 or 0.5, you are bang on what is that you are inherently calculating, even though you may not know what is the definition of a probability or how to compute a probability. Is that you know that when I toss a coin, two outcomes are possible, that is a head or a tail. And since I am asking you what is the probability of a head, head can happen only one time since I am tossing it one time. So you say 1/2 or 0.5 or 50%. What is the probability of it being a tail? Also you call it as 50%. Now the process that we have adopted to get these results, that head and tail, is called a random experiment, right. So there are certain terms that we need to get used to before we actually get into the problems. So the first term that I am going to ask you is, what is a random experiment? A random experiment is basically a experiment that you actually carry out which gives you certain results. In this case, since I am tossing a coin, the results that it will produce are either it is a head or it is a tail. Now if I ask you what is the probability of a head, you said 50% or 1/2 or 0.5, same applies even for a tail. Now this random experiment will produce certain kind of results which we call it as events, okay. So the event is nothing but the coin showing a head, the event is nothing but the coin showing a tail. So these are called events, right. So events are the outcomes of a random experiment. Now in addition to this guys, we also come across a term called unbiased event or unbiased process. Now, before we actually understand this, now the moment I said I am tossing a coin, what is the probability of head? You said 1 by 2. What is the probability of tail? Also you said 1 by 2. Now, is it necessary that probability of head is 1 by 2 and probability of tail is 1 by 2 always? Is there a possibility that somehow I create a coin which has more chance of head falling than tail falling? Yes, hypothetically it is also possible. So, when we are saying the probability of head is equal to 1 by 2, probability of tail also is 1 by 2, our assumption is the coin is unbiased. Bias means basically having some favor, right? So, in this case unbiased means both events are equally happening. That means the probability of head, which is 1 by 2, will also be probability of tail. In this case both events are equally likely in this case, right? So, whenever we are discussing about probability, henceforth we are only discussing about unbiased events. Now, let me ask you guys, let us say I have a die, single die, okay, and I roll a die, right? And if I am going to ask you what is the probability that the number that shows up on the top portion of the die is an even number, what would be your answer? Similarly, I am going to ask you what is the probability that the number that shows up on the top of the die is an odd number. So, what is your answer in this case? Do you think it is the same, and how are we going to do it? So, to do this, basically we figure out, if I roll a die, first I need to be clear that it is an unbiased, okay. So, most of the times we do not say anything because we are under the assumption that all the events that we are doing are unbiased events, okay. So, now my die is also unbiased. Now, I am rolling a die, single die. What is the probability of it being a head? So, before we actually get into that, we should understand what is the definition of a probability. Probability is nothing but what is the chance that you get events in your favor in the numerator divided by the total possibilities in the denominator. So, in this case, if I ask you what is the probability of it being an even number, first you ask yourself how many outcomes are possible when I roll a die. When I roll a die, you can get number 1, you can get 2, you can get 3, you can get 4, you can get 5, and you can also get 6. So, denominator has 6 different possibilities, out of which, since you want an even number, you can either have a 2 or you can have a 4 or you can have a 6. That means there are 3 events in your favor divided by total possibilities, which are 6. So, 2, 4, 6, 3 cases in your favor, total by 6 cases. So, the probability is 3 by 6 or it is 1 by 2. So, same like the previous question, what is the probability of it being an odd number? Again 1, 3, 5 are the odd numbers, denominator is not going to change. So, I will end up getting the answer as 1 by 2. So, guys, remember we are discussing about an unbiased event, okay. Now, when we are discussing about events, guys, there are 2 types of events based on the kind of outcomes that are possible, right. So, first event is called simple event. Simple event. What is simple event? I toss a coin, head or a tail, right, simple event. Now, I also have something called as compound event. What is a compound event? I toss 2 coins at the same time, like this, 2 coins, 1, 2, 1, 2, like this, okay. Now, if I ask you what is the probability that you have one head on the faces of the, at least one head on the faces of these coins, okay. So, we have multiple scenarios. Now, if I toss coin and a coin, 2 coins, then the possible outcomes on both the coins, before I get into the actual problem, is that you can get a head and a head on the face of both these coins, you can get a head and a tail on the faces of these coins, you can get a tail or a head, or you can get a tail and a tail. So, basically you will have 4 different outcomes that are possible. Out of these 4 outcomes, if I want to know what is the probability of getting at least one head. Now, out of these 4 events that I have listed down, check in which of these events you have at least one head. At least one head. So, out of the 4 events, except the last one, which is a tail and a tail, in the remaining 3 events, if you see, you have at least one head. At least one means one or more, right? Like what we have discussed in the permutation combinations chapter. So, here you see 3 events are in your favor, so 3 by 4. Here guys, if you see, this is called a compound event because you have more than one activity that is happening. So, the outcome is a combination of this one and this one. So, this is called a compound event or a composite event. So, basically events are 2 types, simple event or compound event, right. So, these are some of the basic terms that are related to probability. Now, we will try to understand what are the other terms which are basically used while discussing about probability. So, now that we have discussed some basic terms related to probability, let me ask you some of the other interesting things. There are certain terms that we generally come across, something like mutually exclusive, right, exhaustive and equally likely. So, these are all the terms that we will come across as we do problems in probability. So, let me first explain you what are these terms basically mean from a very fundamental level. Again, I am coming back to the event of tossing a coin, right, an experiment of tossing a coin. Now, if I toss a single coin, what is the probability of head? You said the answer is 1 by 2. What is the probability of tail? That is also 1 by 2. If you have observed here that whenever a head is falling, tail will not happen, or whenever a tail is falling, a head will not happen. So, basically mutually exclusive events are those where if one event happens, the other event cannot happen, or in other words, the happening of one event will ensure that other event does not happen. Now, let me ask you a simple question. I roll a single die, right, with 6 faces with numbered 1 to 6. The probability of the face showing an even number, the probability of the face showing an odd number. My question is, are these mutually exclusive events? They are also called as incompatible events. That means they are not compatible, right? So, do you think the example that I gave you, probability of even number, probability of odd number, are these mutually exclusive events? That means whenever the number that is shown is an odd number, you are very sure that it can't be even number. Similarly, when the number that is shown is even number, you are very sure it can't be odd number, correct? So, these are called mutually exclusive events. So, let me ask you another interesting question. Same die example, single die, what is the probability of number showing even on the face? What is the probability the face shows a prime number? That means if you happen to understand what we discussed earlier, even number means 2, 4 and 6, 3 cases out of total 6 cases. So, keep it aside, the probability is 1 by 2. Here I want the probability of it being a prime number. So, what are the prime numbers that are less than 6? 2, 3 and 5. So, there are 3 possibilities. So, here also the probability is 3 cases in your favor out of 6 cases. So, here also probability is 1 by 2. But if you have observed, the outcomes are 2, 4, 6. Here they are 2, 3, 5. So, they are not mutually exclusive, or in other words, so there is a common value between both of these sets. So, they are not mutually exclusive. So, what is mutually exclusive? The happening of one event will ensure the other event does not happen. So, these are called mutually exclusive events. So, prime numbers, composite numbers, even numbers, odd numbers. So, these are all mutually exclusive events. Okay. Now, the next concept that we are going to see is what we call as exhaustive events. For example, if you read newspapers, there are many occasions where you will come across this word. So, let me quote you an example. Let us say you have a robbery, right, near, let us say, a commercial establishment near your house, and you will see in that local section of the newspaper the headlines, or somewhere in the explanation the editor or the person would have written, the police has conducted an exhaustive search of the premises. Now that I have given you the context, you will be able to appreciate it and tell me, sir, exhaustive means you have ensured that everything is covered. exhaustive search of the premises. So here also when I use the word exhaustive, what I mean is that whenever I conduct an experiment, one of the possible events necessarily happen. That means when I toss a coin, either head will happen or tail will happen. That means there is no case that you will get something else, right? Exhaustive means you have covered all of them provided you have done enough experiments. Okay, so this is called as exhaustive event, right? Now the third term that we discussed is called equally likely or equiprobable. So again I am using the word probably. Equally likely events. Now I toss a coin, the probability of it being a head and probability of it being a tail, are they equally likely? Yes. When I roll a die, probability of it being an even number and probability of it being an odd number, are they equally likely? Yes. That means there is no special bias that a head has compared to a tail, or there is no special favor that an odd number has compared to an even number. All these events are equally likely or equiprobable when we are conducting this experiment. So these are some of the terms that are associated with probability. Now you might ask me, sir, what is the probability that we are discussing in our syllabus? So broadly, probability is categorized into two different topics or two different categories. One is subjective probability, second one is objective probability. Now it's very easy to explain you what is subjective and what is objective in general. Subjective means based on your opinion, objective means something which is based on facts. Okay. Now for example, if I ask you guys, what is the probability that India is going to win the upcoming Cricket World Cup or 50-50 overs Cricket World Cup that is going to happen in England? So if you are using objective probability, you will say, since let us assume 12 teams are participating, the probability of India winning the event is 1 by 12. If you don't have any bias or prior knowledge that you are using, just based on a basic rule that total number of teams are 12, India is one of them, so probability is 1 by 12. But if I ask you, is it 1 by 12 or is it more than 1 by 12 in general, obviously you might say that since lot of people are saying that India has a very good chance of winning the World Cup with a good team, probably you will say India has a 30% or 40% chance of winning the World Cup, or some of you might say India can win it 50%, 60%. So when you are using this a number which is based on your own interpretation, based on the performance of the team over the last probably season, 2-3 seasons, you are referring to as subjective probability. So subjective probability is that branch of probability where you are predicting the outcome based on your prior knowledge and which is subject to opinion of the individual. Objective probability is the one which is purely based on facts. So there is no prior opinion or nothing that is used, it is purely based on facts. So what are we going to discuss in our syllabus? We are only going to discuss objective probability. So subjective probability is beyond our scope, and since there is no specific formulae that is related to subjective probability, we don't use it. But objective probability is something that is based on fact, which is basically you can prove using a formula. So what we are going to discuss is objective probability. And also there are certain limitations to the probability that we are going to use, guys. The probability that we are going to use will work only when the number of events are finite. That means when I roll a die, you know the outcomes are only 6 outcomes. But there is a possibility that when we are conducting an experiment, the number of results are infinite. So whenever such cases exist, the probability that we are going to learn, the classical definition, this is called classical probability, will fail. So it works only when the number of events are finite. Second is all the possible events that are happening are equally likely. That means the probability of head is 1 by 2, tail is also 1 by 2. Probability of it being even number is 1 by 2, odd number is also 1 by 2 in our experiments. So our explanation is only subject to the events being finite and the events being equally likely or equiprobable. When the events are infinite and when there are certain bias that is there, where probabilities cannot be predicted just based on regular understanding, our classical definition of probability will not hold good. So please remember this before we get into probability. Now second thing that I am going to explain to you is something related to very interesting topic called odds in favor and odds against, right? So guys, if you remember or if you recall, during this heavy season of IPL where a lot of people are watching cricket, you will see that a lot of people are being caught either doing this betting or basically involved in some kind of activity which obviously is not accepted, right? So you will see some of the people are involved in betting. So when people are involved in betting, guys, the way they actually quote, for example, if you invest 1000, you will get 5000, or if you invest 1000, you get 3000. Basically, if I have to use a formal language to how they call it, I am going to use odds in favor and odds against. So let me explain you with a simple example, okay, right? So what is odds in favor and what is odds against is, let us assume we toss a coin, right, 2 times, 1 and 2. We toss a coin 2 times. What is the probability of it showing a head? 1 head, okay, only 1 head. So the possible outcomes are head head, head tail, tail head, tail tail. 4 events are possible, correct? Out of this, the probability of it being showing 1 head is 2 cases upon 4 cases, 1 by 2. So the probability of it showing a head is 1 by 2, right? If I ask you what is the probability of it showing at least 1 head, as in the previous example, head head, head tail, tail head, all 3 you will take, so you will take 3 by 4. So if I ask you odds in favor, what does odds in favor indicate? Odds in favor tells you there are 2 parts to it. Let's A is to B. In odds in favor, the numerator represents that scenario which are in your favor. The second part or the denominator represents those events which are not in your favor. So when I ask you what is the odds in favor of showing at least 1 head, it is not 3 by 4, but it is 3 is to 1 or 3 by 1, because 3 events are in your favor, 1 is against you, correct? So you can derive the answer from the probability itself. Now if I ask you what are the odds against it showing at least 1 head, 1 event is against you but 3 events are in your favor, then the answer will become 1 is to 3. So remember, total probability, if you know, then you can derive what is odds in favor and what is odds against. So now we have discussed all the different terms that are associated with probability. So let me test you some of the concepts using basic examples, okay. Now first we will start with the same concept that we discussed towards the end, which is odds in favor and odds against, okay. So let me tell you simple example. Let us assume that I am participating in a game of predicting who will be the winner of this year IPL tournament, okay, right. So generally my track record is not so great. So my probability of getting it right, that means my probability of predicting it correctly is, let us say, 3 by 8. When I use the term 3 by 8, you understand that out of every 8 times that I predict, my success ratio is only 3 times out of 8 times. Remember, this is only 3 by 8 may be a simplified value, it may not be the initial value, it may be 30 by 80 or 300 by 800, like a ratio. So when I use the word 3 by 8, I am saying out of every 8 times that I am predicting, I am getting it right on 3 times, which may not be bad as such, okay. Now if I ask you, in this case, since I gave you the probability of me getting it correctly is 3 by 8, what are the odds in my favor? What are the odds in my favor? What are the odds against? Now in this case, guys, if I write down, it is written as 3 by 8. So 3 by 8 indicates out of 8 predictions, 3 predictions I get right. So how many predictions am I getting wrong? Yes, 8 minus 3, which is 5. So what are odds in favor? Odds in favor is nothing but number of predictions in your favor is to number of predictions against you, which is 3 cases I am succeeding, 5 cases I am failing. So it is 3 is to 5. These are called odds in your favor. Now what are odds against? Odds against means basically reverse of odds in favor. That means how many times I am failing, which is 5 times, is to how many times I am succeeding, which is 3 times. So the answer will be 5 is to 3, correct? So basically we use the concept of probability in many cases, like tossing a coin, right, rolling a die, or even picking a card from a pack of well shuffled cards. Okay, so that we will discuss when we deal with the problems, but let me ask you more examples just to ensure that our concept of probability is very strong before we get into the problems. Okay, now I am rolling 2 dice, right? Let us say I am playing a game, so I have 2 dice. Now let us say I have rolled it to basically play a game, let us say snake and ladder. Okay, right? Now if I ask you what is the probability that sum of the numbers that are shown on the face of both these dice will add up to number 7. So my question is, how do I even know how many cases are possible and how do I even get the number 7? You might say, sir, 7 is possible many scenarios. So how is it possible to actually derive this answer? To understand this, let us first write down what the possible cases, then from the next experiment you will be able to appreciate how we are able to get it a little faster. Now tell me, what are all the possible numbers that you can get on the first die? So let me write down 1, 2, 3, 4, 5, 6. So all the possible numbers on the first die are 1, 2, 3, 4, 5, 6. What are all possible numbers on the second die? They are also 1, 2, 3, 4, 5, 6. So you can have 1 comma 1. When I use the word 1 comma 1 in these brackets, the first part represents the number on the first die, second one represents the number on the second die. Now you can also have, keeping 1 on the first die, you can also have 2 on the second die. Similarly, you can have 1 comma 3. So what will be the next? 1 comma 4. What can be the next one? 1 comma 5. What can be the next one? 1 comma 6. So you have seen that when I put 1 as the outcome on the first die, the second die can have 1, 2, 3, 4, 5, 6, 6 outcomes. Similarly, with 2 also you will have 6 outcomes, with 3 also you will have 6 outcomes, 4 also 6 outcomes, 5 also 6 outcomes and 6 also 6 outcomes, where my last possible answer is 6 comma 6. So the number of outcomes that are possible on the first die are 6, the number of outcomes that are possible on the second die are 6. So total possible outcomes are 6 into 6, which are 36, which I have written for you, right? So how many outcomes are possible? 36. So what will come in the denominator, guys? What will come in the denominator is 36. It can maybe 1 1, 1 2, 1 3, 1 4, 1 5, 1 6, 2 1, 2 2, 2 3, 2 4, 2 5, 2 6 and so on 6 1, 6 2, 6 3, 6 4, 6 5, 6 6. So 36 different possibilities exist. That is what will come in the denominator, total possible cases. But I am interested more in getting a sum of 7. So die 1 plus die 2 should give me 7. Now tell me, sum of two numbers is equal to 7 and the condition is no number should exceed 6. Agreed? Because the maximum number that you can have a die is 6. So basically I need to limit myself to not exceeding 6 in any possibility. Correct? So let me first try with 1. So this will become 6. Let me put 2 here. This will become 5. Let me put 3 here. This will become 4. Let me put 4 here. This will become 3. Let me put 5 here. This will become 2. Let me put 6 here. This will become 1. So you may be wondering, these 3 and these 3, are they same? Are they any different? They are different, because what we are interested in, what is the outcome on the first die plus what is the outcome on the second die. Together they should be 7. So 1 and 6, 1 on the first die and 6 on the second die is different from 6 on the first die, 1 on the second die. So here, just like we have discussed in permutation combination, we are more interested in the order also. So how many outcomes are in your favor which are adding up to 7? There are 6 possible cases out of 36 possible cases. So the answer should be, probability is nothing but cases in your favor divided by total number of cases. So the answer should be 1 by 6. Always we will simplify the value. Okay. Now let me ask you a simple question. In the same experiment, now I am going to ask you, what is the probability that sum of the numbers on their face is equal to 8. Now we discussed about 7. Now I am going to ask you 8. So please tell me what is the denominator. Is there any change in the denominator? No, because if I am rolling a die twice, total outcomes are 6 into 6, that is 36. Now I want the total sum to become 8. So tell me what are the possibilities. Can I write 1 comma 7? No, because 7 is not possible. So can I write 2 comma 6? So guys, remember henceforth whenever we are writing 2 comma 6, also remember instead of writing 6 comma 2, just count 2 comma 6 2 times. That 2 comma 6 means 6 comma 2 is also included. Similarly, 3 comma 5 means 5 comma 3 automatically comes. Now 4 comma 4. Now my question is, if I write 4 comma 4, can I again write 4 comma 4? Technically no, because 4, 4, both numbers are same, I cannot count it 2 times. Whenever the number repeats, you have to count it only 1 time. So total how many cases are in your favor? 5 upon 36. So this is the probability of the sum becoming 8. So this is a very simple question, guys. Okay, so let me ask you a question with respect to tossing a coin. Okay, now let us assume I toss a coin thrice. 1, 2, 3. I toss a coin 3 times. Now I ask you, what is the probability of head showing on only one face? What is the probability of the head showing on only one face? Now my question is, first I should know how many events are possible, which is my denominator. First coin, how many outcomes are possible? 2. Second coin, how many outcomes? 2. Third coin, 2. So 2 into 2 into 2, which is 8. So which are those 8? So if I list down head, head, head. So please write down yourself also. There is no standard order, but ensure that you write it in a proper fashion so that you can cover all the 8. Head, head, tail, head, tail, head, tail, head, 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 tail, 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 head, tail, 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 head, tail, tail, tail. I started with 3 heads and I have taken 2 heads and I have taken 1 head and no heads. So if you see 1, 2, 3, 4, 5, 6, 7, 8, there are 8 outcomes that are possible. So denominator is always 8. So my question is, what is the probability of it showing only 1 head? 1 head, what are the possibilities? I will take those 3 cases, so it will become 3 by 8. So what is the probability of it showing only 2 heads? This is also 3 by 8. What is the probability of it showing at least 1 head? If I use the word at least, that means you can have 1, you can have 2, or you can also have maximum 3. So excluding this, out of 8 events, what is the probability of it showing at least 1 head? If I just ignore this, I will have 7 by 8. Correct? Now using this, we can frame multiple questions. Okay, right? So these are some of the basic examples related to probability. Now next we are going to learn something related to set theory and its relation to probability, or how do we learn it using the concept of Venn diagrams. Okay, right? So that we will, let me draw those figures and we will try to understand its relation to set theory.